Oh, hi, all. All right. Sometimes you watch the news and the weatherman would say there will be scattered showers for today. What does that mean? You're right. There could be showers on different spots of your area of your community. Now, sometimes you'll see a graph, and there are dots all over the place. And sometimes the dots are organized, sometimes they're not. You call that scatter plots. And guess what? There is math behind those scatter plots. And that's the lesson for today. Now, these are examples of real life scatter plots. All right. For example, you would see this done by businesses, done by scientists, and you would see what? You would see different ways that the dots or the scatter plots are scattered all over the graph. All right. Sometimes you see a pattern, sometimes you don't. But in real life, it could predict values. Okay, let's check this out. Now, for example, you got a table. You made a survey of the age of students and their height. This is a table, right? Now, okay, and then you plot them in a graph. Okay, this will be your x values, and these will be your y values. Okay, the ages are here, that's the x, and the height went over there, that's the y. Okay, those, for example, the first one is 1. The age of 1 has a height of 29.4, and this is that dot. Okay, the second one, 1.5, and the height is 28.2. All right, so we plot all those points, and that is called the scatter plot. But guess what? Very important definitions are the following. The x is called the independent. Independent. And then the y is now called, the y values are called dependent. From the word depend. All right, which one depends? Okay, the height depends on the age. All right, maybe the older you are, the height gets higher, right? The younger you are, the smaller is your height is. So again, the height is depending on the age, therefore you are a dependent value. But the age could be anything, so you're independent. It could be any age. So now let's review our definition. We use a scatter plot when your independent variable has multiple values for your dependent variable. Remember, every graph has two variables, the independent, the one on the x, that is typically graphed on the x-axis, and the dependent, that is typically graphed on the y-axis. An independent variable is the controlled variable. All right, so I repeat, this will be the one on the x is the independent, and then the one on the y, this is the dependent. Okay, so remember those two vocabularies. Now, let's have another example. So the temperature and the ice cream sales, they are being compared. Depending on the temperature, the sales will increase. Can you see that? So again, the temperatures, all of these data were plotted in a graph. And these are the results. Check out the points, all right? So what have you observed? There's a trend that the point is going up, right? It seems like it's going up. So what do we mean by that? The higher the temperature, what can you say? The higher the sales are, okay? And the lower the temperature, the lower the sales are. It makes sense, right? Do you buy ice cream during winter time when it's really cold? No. That's why the sales are down. But when the temperature is high, that's the time people go to ice cream parlors, therefore the sales gets higher. Remember, this is the independent and this is the dependent. All right, so a scatter plot would always come from a table, okay, table of values x and y. And then we always plot them on a graph, okay? So they're not always lying on a straight line. They're scattered. But check this out. If the scattered plots would form from left to right going up from left to right going up, you call that positive trend, meaning as one value increases, the other one increases too. They affect each other directly. Now, if from left to right, the trend is going down like that, you call that a negative. What does that mean? As one value increases, the other value decreases. It affects it on an inverse way. But, from left to right, you don't see any pattern. It's not going up, it's not going down, it's not just stagnant. Therefore, there is no relationship at all. They are not related. So, no trend. Okay? Remember that. Positive trend going up, negative trend going down, and no relationship at all. Now, let's see which is the dependent and which is the independent. All right, so let's read this situation here. Roxanne is making sandwiches for a family picnic. The number of sandwiches she can make depends on how much bread she has. Okay, S is the number of sandwiches Roxanne can make. B is the amount of bread Roxanne has. Which of the variables is independent and which is dependent? Okay, let's see. If we're going to graph that, okay, which depends on what? Who stays on the X? S is the independent variable and B is the dependent, or B is the independent and S is the dependent. So remember, the number of sandwiches you can make depends on the bread. So the bread goes here. That's the bread. The more bread you have, the more what? Sandwiches you can make. Okay, so bread goes here. Bread is the what? The X is the independent. The Y is the dependent. So B is the independent and S is the dependent. So that's the correct answer. Okay, next. Let's try the next one. Laura is making fancy headbands for the hair to sell at a crafts boutique. The more ribbons she has on hand, the more headbands she can make. So, if you're going to graph that, where will be the supply of ribbons? Ribbons could be any number. Depending on the number of ribbons, which will depend the number of headbands. Headbands over here. Okay, so headbands is H, R is ribbon. Again, R is the independent and H is the dependent. Yes, the headband depends on the ribbon. So this is the correct answer. Got it? All right. Next, let's look at these Ingenuity problems. The scatter plot below was created from a table of values and represents the relationship between the number of seconds spent doing sit-ups and the number of sit-ups completed. Okay? So the more time you spend, okay, which is dependent on that. The sit-ups will depend. Okay? There could be more sit-ups done. Okay, very good. So, and you could see the trend, it's a positive one. Okay, let's see now. Assuming that none of the data points overlap. So each point is a distinct is a separate record compared to the other. And that all of the data points were plotted. How many data points were in the table? Where did these dots come from? Okay, how many from a table? Let's count then. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 datas coming from a table. Got it? Okay, next. Wyatt wants to study the relationship between the number of siblings that the student has. Okay, if this is you have siblings, okay? And the student's grade point average, all right? And you want to see the relationship between your grade and the number of siblings, all right? The more siblings you have, what happens? Does it affect the grade? The less siblings you have, does it affect the grade? He believed, okay, what did he believe? That if the points form a straight line, then there is a relationship between the two variables. Which scatter plot proves that Wyatt's statement is not always true? Okay, so this could happen, all right? The more siblings you have, the lesser your grade is. That's possible. All right, possible. All right, here. How about this? Look at this. A positive. The other one is a negative. This one means the more siblings you have, the higher your grade point average. That's also possible because a lot of siblings can help you. Is it also possible that this one, number of siblings, point average is this? It varies. No trend. This is possible. Possible, no trend. But is this possible? The more or the more siblings you have, the grade is always the same. The less siblings you have, one, the grades are always the same. It's just always the same. Your grade will always be 3, whether you have one sibling, two sibling, three sibling. Okay? So this is always not always true. This could happen, this could happen, this could happen, but not this all the time. Got it? All right, so let's read the situation. Suppose there is a relationship. There is a relationship between independent and dependent variables represented in a scatter plot. Which statement is correct? Only one statement here is correct. Okay, let's look at the dependent and independent first. Let's say this is the independent. This is the dependent. Okay, let's say this is the number of hours of study. Let's just give a concrete example. And this is the grade you get. All right. So let's see. The independent variable, this one, change in the dependent variable only if the points in the scatter plot go up from left to right. Only when it goes up from left to right. It doesn't have to be like that all the time. It could be the reverse. So not that. Next, number one, no. Let's look at the last one. The dependent variable influences change. Does the dependent influence the change? No. It's the independent who influences the change. So that's wrong. The dependent variable influences the change. Again, it's not like that. It's the opposite. It's the independent that influences change to the dependent. So let's look at the second one. The independent variable influences change. Yes, but how? Whether the points on the scatter plot go up or down from left to right. It's not only go up, it can go up, it can also go down. So which is the most complete answer? The second one. All right, that's the correct answer. All right, for this one, there are 4 things that we need to analyze. Let's start with number 1. When analyzing the number of home runs that a baseball player hits over several seasons. So these are the 2 variables. Okay? So where the season come in? The season is the independent. So the season is the X. So the number of seasons will determine the number of home runs. Home runs. The home run depends on this? Yes or no? Yeah, it makes sense. Okay, this one makes sense. Let's check the others though. When analyzing the number of umbrellas sold with the varying amounts of rain, okay, let's make a graph on that. Amount of rain and the umbrella. If the number of umbrella that are sold is the independent, this is the umbrella, number of umbrella, and this is the amount of rain. Amount of rain. Does the amount of rain depend on the umbrella? The number of rains, the amount of rain depends on the number of umbrella you see there? No, it's the opposite. So this doesn't make sense. It doesn't depend. Okay, let's look at the third one. When analyzing the number of registered voters by age, and age, okay? It's saying you now the age is the dependent. So the age is here. This is the number of voters. Does your age depend on the number of voters, or the number of voters depend on the age? Depend? No, it doesn't work like that. Okay, let's look at the last one. When analyzing the number of students that ride the school bus for each day of the week, and people in the school bus. The day is the dependent. The day is here, dependent, and this is the number of students. Number of students. Does the day depend on the number of students? Does the Tuesday, the Wednesday, or the Friday depend on the number of students? Okay, depend. Question mark, no, it doesn't. It's the opposite. The number of students in the bus will depend on what day it is. Is it a weekday or a weekend? Okay? So therefore, the only logical thing is the first selection. All right. So that's our lesson for today. Remember, results is equal to action plus motivation. Good luck.